Kia ora Year 12. This is a question for Cian from the November 2019 paper, paper 31, and it's question 6. So it's got a little proof in it for 2 marks and then a nice integration by parts question. So let's look at the proof first. So by differentiating this, show that if y is equal to cot x, then dy by dx is negative cos x squared x. In other words, one of the standard results we get in our formula sheet. So we're going to do that, and then we have to do this, show that question. So we're going to integrate x cos x squared x dx between these limits. So you should be able to see pretty quickly that this is going to be integration by parts, and we're going to use this result that we've got up here, even if we can't do that proof. So when we're integrating cos x squared of x, we can see just from that first part that we will integrate and get back to negative cot x plus c. So we're going to use that. Right, so let's look at part 1 first up. So we're going to differentiate cos x over sin x because they've told us to do that. So the obvious thing to do here is to use the product rule. So dy by dx will equal sine squared of x. So first of all, squaring the denominator, copying that up to here. Now we're going to differentiate cosine of x, which is negative sine of x, minus the other way around. So now we differentiate the denominator, so minus cos x times the numerator. And if you still want to use u and your v, go for it, that's fine. So we need to get down to negative cos x squared of x, which of course is negative 1 over sine squared x. And you can see we're just about there. We've got the sine squared x. And in the top line now, we're going to have negative sine squared x plus cos squared x over sine squared x, which is equal to negative 1 over cos x, negative 1, going too fast, negative 1 over sine squared x, which equals negative cos x squared x as required. So that's the first little bit done. Okay, so now onto the integration by parts, and you can see that we want to end up with pi on 4 plus a quarter of log 4. I'll just get rid of this, get some more space back, and I'll make the pen a little bit skinny. Oh, we might use the nice sparkly pen because this might be the last video for the year. Right, so we've got from pi on 2 to pi on 4, and as I said, it's going to be IBP. So let's look at what we've got. Well, we've just shown that we can integrate this. And this one we're going to first of all leave and then differentiate, right? Because it's going to get easier when I differentiate that and get to 1. So we'll have integrate here. Okay, so different ways that you can set this out, but let's first of all leave the x and then integrate this. So I could write this as negative cot x, but I'm just going to leave it as negative cos x over sine x because I've got some exact values and I'm going to be better off, for my brain anyway, working with pi on 2 and pi on 4 with cosine and sine. I'm sure lots of you will do that with cot x, and that's totally fine. And then I'm going to subtract the integral at the same limits. I'm differentiating now. I'm going to differentiate my x and get 1, and I'm going to integrate cos x squared and get negative cos x over sine x dx. Now this is where you really see the benefit of, oh, where's it gone? This is where you really see the benefit of leaving it like this, because it's pretty obvious straight away now that to integrate this, I'm going to get a log. So keeping on going, get rid of this mess. Let's just leave this sitting here. Oh no, you know, actually I'm going to evaluate this bit now because it's pretty easy to do. So I'm going to have pi on 2 times, so negative cos of pi on 2, there's my cosine graph, it's going to be 0, right? So 0 over 1 minus pi on 4 times negative 1 on root 2 pi over 1 on root, not 2 pi, 1 on root 2. So that's that bit done. And now I've got plus this integral here, so pi on 2 to pi on 4 of cos x over sine x dx. Okay, let's clean up this first thing here. So this is getting close to my final answer already. This is 0, and this is going to be plus, that's 1, so it's just pi on 4. So that's nice. And now we've got the integral here, which works out to be the natural log of sine of x. Now let's just check that we haven't mucked up any sign errors. When I differentiate sine of x, I get cosine of x. So it's correct that it's just the ordinary old log of sine x. So now we get pi on 4 plus the log of sine of pi on 2. So sine of pi on 2 is 1 minus the log of sine of pi on 4, which is 1 over root 2. Okay, if you still got to draw your triangles, all good, just don't muck that up. Now, we're not quite at the result we want, but we can work that around. So that's pi on 4 plus 0 minus the natural log of 1 plus the natural log of 2 to the power of a half, which is pi on 4 going very slowly here. So pi on 4 plus a half log 2. So we get to here and we go, hang on, I'm not getting anything with log of 4. What's the problem, right? So we need to get to this, a quarter times this. So we just have to force through a common factor of a quarter. Let's see, we've got 1/4, and now we've got pi. And to make this 1/2, we need to have 2 log 2. So there you go, that's how we get our natural log of 4. So we get our final answer, putting this all back together into here, 1/4 of pi plus the natural log of 4 as required. So quite a nice question. No particularly difficult individual steps, I don't think. You've just got to keep your wits about you with your trig integrals and derivatives and making sure you don't make positive and negative errors. Thanks for watching. Please, guys, if you've got any last questions, send them in and I will get onto them as soon as I've done the dishes.